This is AQA GCSE Dual Award Science. It's the chemistry topic, chemical changes. And we're going to start by looking at the reactivity series. I'm going to recommend that you try each activity pausing the video as you go. So in this first example, we're going to look at common metals and how they react with water and dilute acid. Some of that is a very brief recap of work that was done in Chapter 2. Using experimental results to deduce an order of reactivity in metals, explaining oxidation and reduction in terms of loss or gain of electrons. That's going to become more important actually later within this topic. And predicting reactions of unfamiliar metals given information about their relative reactivity. Again, that's something that will develop as the topic goes on. Now, in terms of practicals that you've already seen, you will be familiar with lithium, sodium, potassium reacting with water. But we also know that there are lots of metals that don't react with water. And this practical that you've possibly carried out allows you to instead react some metals with acid so that we can see if there is any difference in their level of reactivity. Because by using the observations that we make here, we can start to determine an order of reactivity and start to build a reactivity series. Now, in terms of observations that you're going to make with these four metals, have a think about what you would see. And the first thing to say is that copper, there will be no visible change. Copper does not react with the dilute acid. Zinc and iron, there would be some effervescence. You would get some bubbles forming on the surface, but actually they would be very, very similar to one another. You wouldn't necessarily be able to say one was more reactive than the other. Whereas magnesium would give much more vigorous effervescence. All of these observations you will be expected to be able to recall in an exam. So in terms of an order of reactivity, magnesium's definitely the most reactive, copper is definitely the least reactive. We probably couldn't say on the basis of this practical with any level of confidence whether zinc or iron were the most reactive. Now let's use this opportunity to have a think about control variables. What might we want to keep the same in the experiment that we have just seen? In the first instance, you would want the same volume and concentration of the acid. If you use a more concentrated acid, that might speed the reaction up and then we can't compare it. If you use a greater volume, the same thing might happen. Similarly, if we go to a higher temperature, that might have an impact on the vigour of the reaction. So we want to keep the same temperature. And with the metal, we want to use the same mass of the metal ideally, and were it possible, we would use the same surface area. So it might be that they're all a finely ground powder. It might be that we use 1 cm cubed blocks of those metals, so we can compare and contrast. And the purpose of control variables ultimately comes from an understanding that the independent variable is the thing that we choose to change in a chemical reaction. The dependent variable is the thing we choose to measure to see what impact our change to the independent variable has had. So if we want to see what impact changing the independent variable has, we don't want any other variables to change. So we try to keep all of the others the same. Now, we're going to talk a little more in later videos about how the order of reactivity is determined, but this is a neat summary of the reactivity series of metals, and you are going to need to learn it. You're going to need to know this order. There's a lot to take on. But actually, there's a lot that you already know. If you're familiar with potassium, sodium and lithium from elsewhere in chemistry, potassium ignites in cold water, sodium a very, very vigorous reaction, lithium's a pretty vigorous reaction, so it makes sense that they are at the top. Similarly, we know that gold and silver are very unreactive. We can wear it as jewellery, they don't tarnish, nothing really happens to them. And copper's also very unreactive, it's used as water pipes. So we're actually well on the way to learning it with things that we're hopefully quite familiar with. Different take on the reactivity series here, and it includes two elements that might seem unusual. What are they and why? And the two that really stand out are carbon and hydrogen. And the reason that they stand out They're not metals. We're going to find out in later videos why we include them. And I've put a suggestion here to make a mnemonic to help you remember the reactivity series. I'm not going to give you a mnemonic. It's a great opportunity for you to come up with something that will help you remember. So a really good, striking visual image that mnemonic will give. Your question, I suppose, is whether you use the element symbols or the element names to make that mnemonic. That takes us to the end of this video. Thank you for listening and goodbye.